Statistical thinking involves reframing our experiences into new representations that help us identify meaningful patterns in the world. So let's see an example. Imagine that a new cupcake shop has opened up in town and I'm considering if I should spend my hard-earned money on a cupcake. Are they even any good? So let's say I open up a booth outside the bakery and I ask everyone who comes out to rate their cupcake on a scale of 1 to 10. And now, every time I ask someone this question, I write their score down on one of these cubes. So, after I intercept a whole bunch of people coming out of the cupcake shop and I collect their ratings, I have a whole bunch of cubes. So, what's happened so far? The cupcake shoppers converted their real experiences of eating the cupcake into a rating at the 1 to 10 scale. And then I converted that rating, which existed in their heads, into one of these numbered cubes that I can hold and I could store them and I could stack them. Why are we doing all this? Well, what we have right now is just a pile of cubes, and this is pretty hard to make sense of. So we're going to make something called a histogram now. It's a way of organizing our data into a tidy visual so that I could better spot some patterns. The way it works is that I'm going to stack all of the cubes that are very low on them together. So I'm looking for any ones. There are no cubes. Nobody rated it a 1, but we have cubes where somebody rated it a 2. And then I can stack all of the 3s together. That's it. And then I can stack all the 4s and the 5s and the 6s, the 7s, and an 8. Okay, so now let's look at this. Instead of a messy pile of cubes, we're looking at something else. We call this a distribution. We can see how the ratings are distributed from low over here to high. And we can see that there's a lump in the middle around 5, but there is some variability. Let's take a minute with that word, variability. If everyone gave the cupcake the exact same score of a 5, there would be no variability. We would just have a stack of cubes that say 5, but instead we have this shape. Because not everyone gave the cupcake the exact same rating, and the variability makes our data a little more complicated, but also a little more interesting. And even though there is some variability, not everyone gave the cupcakes the same score, there is a pattern, and that's that there is a bump here around 5. And that's because more people rated the cupcake a 5 than any other number. And most people rated the cupcake between 4 and 6. Only a few people rated the cupcake 3 or lower, and only a few people rated it 7 or higher. So, if I think I'm anything like the people that I surveyed in front of the cupcake shop, I could probably learn something from this distribution. I expect that I will probably give this cupcake somewhere around a 5, maybe a 4 or a 6. Not incredible and not terrible either. And this is the essence of a very fundamental process in statistics. We find a way to represent something in the world as data. In this case, that was people's experience of a new cupcake shop. And we put that data into a form that we can count and visualize. That's the blocks. Then we organize the data. In this case, we stack up the blocks with the same rating so we get a histogram. And we do this all so we can understand how the data is distributed and begin to see patterns. Most of the time, researchers use computers, not wooden blocks, to represent and store and manipulate data. But what I've shown you is an analog version of a process that statisticians do with software. With only a handful of data points, the cubes representing people's ratings of the cupcake shop, you might be able to make sense of some of the big patterns even without making a histogram. Maybe I could have just looked in the bag and noticed that there were a lot of 5s. But you can imagine that if we had hundreds or thousands of data points, it would become even more important to make the visual, and of course, to use a computer. The bottom line is that we can use this histogram as a handy way to see the distribution of data. And from this distribution, we can begin to notice some features like the peak. The peak is really important because it's telling us a lot of people rated the cupcake around 5 out of 10. So that probably means I'm also likely to rate it that way, seeing as I think I'm pretty like the people that were coming out of the cupcake shop. So see, I'm learning something from the data. Next up, we'll formalize some words that people use to describe the peak of a distribution: the mean, and the median. We'll talk about what those statistics can tell us and also ways they can mislead us. And I will eat this cupcake because I know it's not likely to be the best cupcake I've ever had or the worst, and that's okay with me.